Hello, everyone. For our next speaker, we have Yash Mehta, a technology consultant with a wealth of experience in delivering complex, cutting-edge projects. Yash is an expert in AI, ML ops, real-time data processing, and cloud architecture. He's also one of the Google Cloud Champion Innovators in the ANZ region, specializing in cloud AI and ML. Today, Yash will be discussing building accurate and reliable AI systems by grounding on your private data. Expect to learn about tools like retrieval-augmented generation, custom model training, and secure data governance. Let's give a warm welcome to Yash.
And am I audible to everyone? Okay, I think I'll just use this one. Can I turn it? Is it on? No, it's not.
Test.
Okay, thank you. Thank you. Good morning. So before we start, I'll ask a few questions. How many of you have ever created an AI-based system or used applications which use LLMs on the back end? For example, Copilot? Please raise your hands. Okay, good. And how many of you did attend Patrick's session before this? Okay, so there would be a few overlaps between our sessions, so I will skip some of them, but also cover them quickly. I'll skip my introductions because you've already been introduced. Today, we'll be talking about why LLMs are not enough. So we've already discussed what LLMs can do, but what LLMs cannot do. We'll discuss about what is grounding and how grounding would help LLMs help you better. What are the services provided by GCP? Because this is Google DevFest, we'll talk about GCP services as well. What are the services provided by Google to help you build your own systems? There would be a short demo because we are a bit late already, and there would be a question time at the end. What exactly is AI? Everyone's been talking about AI, but what is AI? Any system, set of rules that can do tasks at a human grade can be classified as AI, right? Maybe it can play chess. AI. It's a very generic set of systems or rules. Then there's a level below it, which is machine learning, which is a subset of AI, which uses data to learn patterns. Then we have deep learning, which uses neural networks to learn from a much more bigger set of data. And then the Gen AI, which is all everyone's been talking about. It's more like a generator and a subset of deep learning, which would create new data based on what it's learned. So ChatGPT, Gemini, all of that, they've learned something from a massive corpus of data. They've learned all sorts of relationships between data, and now they just use that memory to generate data. So now that a lot of people already know what LLMs are, you've used them, why are they not enough? Let's start with a question. I'll ask a question to Gemini about Vivanti. What does Vivanti do? And Gemini says it's a management consulting firm, which it is not, that specialize in improving customer experience, which we do. But if you see, it's clearly hallucinating here. It doesn't know what it's talking about. and make sure I've checked this box which is ungrounded, so it does not have any contextual information. It's just generating something based on the weights. Let's do the same with ChatGPT as well. Some people think ChatGPT is really good, right? It's a bit better. It says it is IT service and solutions company, which is better, but then it says specialization in SAP, offers service system integration, yes, but it's still not accurate. It does something, it creates something. If I ask the same question again to ChatGPT, it would say something else. So it's not giving you reliable and accurate answers. Another question. I've asked this question to ChatGPT 4 and Gemini Pro both, and it's what's a compass? So it's something we have something at Vivanti which is an accelerator kind of a thing, but if you see, both of them don't know what a compass is in this context. So if it's a chat application that I've built for my company, and the user comes in and asks a question, they're not getting the answers that they need. That's where LLMs lack. They don't have access to your private information. They do not understand the context. They do not understand what is required for this specific scenario unless you explicitly ask it to do that. So that brings us to the first point, which is lack of domain-specific knowledge. It doesn't know the domain knowledge because it's been trained on a general data set back in 2022, I think, was the last cut-off date for most of the models. They do not have access to your private data, as you saw. They didn't know what we do. It lacks governance as well. So there's no governance. How did the model generate the output? Why did Gemini say that it is a management consulting firm? How did it create that? It was just a bunch of neural networks, weights connecting to each other saying, oh, this is what I know. But was it actually true? How did it find that? We have zero auditability and no understanding on why it created that answer. And as a result, it can hallucinate, it can generate inaccurate results. And also, we cannot have access controls set at an LLM level or a system level, for example. If I ask an LLM the same question versus someone else asking the same question, you usually get the same answer on the same context. But can you have an application which could have different set of answers for different people asking the same question? You can't. And finally, privacy, which again links back to the fine-grained access control. Can some people access only a few set of information? Some people can have more information. Can LLM do that? No. And also, this is something that a lot of people are worried about, is sharing data between external providers. So if you have your system sitting somewhere and you have an LLM provider, ChatGPT, your data goes to OpenAI's data center sitting in the US. So all sorts of concerns. And there comes in grounding, which does not solve all of the problems, but it solves quite a few of them. And we'll talk about which ones. But what is grounding? It's giving your LLM or your systems access to knowledge or information or real-time information, I'd say, in certain scenarios or specific domain context to generate more accurate answers, more reliable answers, and also hallucinate less. So what are the problems that grounding can solve? So a few of them. LLMs lack domain understanding. You can provide that domain-specific understanding to your systems with grounding. So you can provide access to private data so that LLMs can use them. Governance, you can have an auditability. You can have a system that can be audited on how the outputs have been generated. And you can also have fine-grained access controls. So some people can have access to a certain set of data. Some people have access to some other set of data. And they can all get answers based on what they have access to rather than what the LLM has access to. So you can pass all of that to a grounded system. What are the ways to ground it then? Few-shot learning. I think some people were there in Patrick's session, so you know what few-shot learning is, right? Okay. Few-shot learning is guiding the behavior of your application or your LLM, I'd say. What? Interesting. That's okay, but it's back. So it's guiding your application or your LLM to get to a certain point with examples. So you could just give out a few examples as a part of your prompt and then ask your question. So it's like a workbook quiz. You get some examples, you see how the questions work, and at the end of your lesson, you have a question, and you try to answer it. So let's see an example here. Not the best format, but if you see I have a question, this is awesome. The answer is positive. So that is, I'm trying to get sentiment out of it. My next question is, this is bad. The answer is negative. So I give a few examples here, and finally I ask the question, what a horrible show. And all these LLMs give me the same result. Because I'm guiding them in a way, I want the results to be generated. So that's few-shot learning. And it's not a standalone technique. You would use these in conjunction with RAGs, agents, fine-tuning. You can use it in conjunction with all of that to get a more reliable answer, more structured answer. Next in this journey is fine-tuning. It tailors your model to understand domain-specific information. For example, you have, in some examples that Patrick mentioned, was you have medical use cases. So you would already know some input-output pairs. You would use that to train your LLMs or train your models. I've been saying LLM a lot, so I'll use models now for a few times. You would use input-output pairs to train your models so that they can generate output consistently. And just as an analogy, it's more like studying for an exam. You learned, an LLM learned, a model learned, based on what it was taught, and then use that in an exam. So now if you ask a question, it would try to get back from what it was learned, what it learned, use those weights to generate an output. So most of the models that you see out there, Gemini, be it ChatGPT, Gemma, Llama 3, all models have been trained on a massive, massive set of data. So they already have all those weights, they already have a general understanding, but they do not have understanding of your use case. So fine-tuning comes in and it adjusts some of the weights based on the data that you provided, which is usually much more smaller compared to what they've been trained on. But it only adjusts some of these weights to optimally tune your models for your use case. And that's pretty much fine-tuning. And that's my favorite one. It's retrieval-augmented generation, which is the next step. And this is, again, not a standalone system. You can use it with RAGs. You can use fine-tuned models for RAGs. And what it does is it provides a context, which is the relevant information for the question, to your LLMs to generate the desired outputs. So that also helps us get real-time information. So if you have a good backend that has data that comes in every 30 minutes, let's say, or every hour, or even real time, when someone asks a question, your LLM could access those. Because there's a retriever that sits before your LLM, you could always get real-time information for answering those questions. And it's auditable because the retriever would give and fetch most closely related context. So you know that these are the 5 pages that my LLM used to generate an answer. So you can audit that my LLM system, my application, is not randomly generating an answer. It's using this specific set of context to generate the answer. And continuing the analogy, it's like an open book exam. When you have a book in an exam, you've been asked a question, you don't know the answer, but you can still look it up. It's exactly the same. And as a high-level overview of how the flow works for a retrieval-augmented generation, it's when you ask a question, there's a retriever that sits before your LLM. So your question never goes directly to the LLMs. There's a retriever that finds the most relevant information that you have on your vector databases, feeds that to the LLMs to generate an output. So you get a more consistent output, you get a more reliable output, and it's pretty sure that it's not going to be hallucinating. It can still hallucinate? Yes. Okay. In technical terms, it's a prompt. In a very technical terms, it's a prompt. So the retriever would fetch all the information as context, pass it alongside your question, and ask your LLM to only use this context to generate the output. It could be any amount. It is mostly tailored for your use case. Oh, plain text. So as a prompt, it goes in as plain text. But your context, when it's being fetched, it's a vector database, usually. It could be something else, but usually it's a vector database which would do a similarity search for your question, and it would find the relevant documents which are very similar to what you're looking for, fetch all those documents in plain text after that, and pass it on to LLMs as plain text. Yeah. So within RAG, there are no weights. Weights usually come in when we are fine-tuning. And within RAG, we don't have input-output pairs usually. RAGs would only have the information that is relevant. So let's say there's a company bio page where it's mentioned that someone, like these are the people who work at Vivanti. So we just vectorize that into a database and store it as a vector into a vector database. So now when someone asks, who's the CEO of Vivanti, it would look up the page and find, because it's vectorized, it can do a similarity search and find only the relevant information and pass it on to the LLM. Yes, let's do that. Okay, so hopefully that's clear on how RAGs work. And this is the new-ish method for creating applications is agents. People have been talking about agents all the time now. So agents have access to external APIs. They do have access to functions or tools, they call it, to do some tasks. And those tasks could have a retriever in it, probably. Or they could actually perform actions, say, insert a new record for me, or maybe delete some records from me, or update my database somehow. So all of that actions can be performed by agents. And again, this is an auditable process because you know what tool was used and when it was used for what purpose. And it's very auditable that you can log all of that. Coming back to the analogy that we have been discussing, it's like an open-ended book. Open-ended exam. You have access to books, you have calculators, you have a computer sitting with you. You just get me an answer. Just do what you're supposed to do. So it's a one step further from RAG approach, which can have access to anything. Maybe you have a very business-specific calculation that your agent needs to do. You can create a new agent or a new tool that can do a business-specific calculation. And when your supervisor agent gets a request that, oh, what's the rate, for example, then your tool can, so your supervisor agent can call the tool to do the calculations and then return the results back. So it's a more free-flowing kind of a system where your supervisor LLM would pick what agent or what tools to choose to generate the final output. You can still prompt it to use a few tools in a sequence, but usually it's much more free-flowing compared to RAG. Comparing all of these to see how they actually solve our problems that we discussed in the first place. Understanding of unique terminologies and processes. Few shot usually no. It's more for just guiding to your outcomes. Fine-tuning, yes, because you have an input-output pair. You're showing what it's expecting for a definition. So it would start learning your unique processes or definitions. RAGs and agents, they usually don't learn, but they can still be provided as a context. So they understand with the general assumptions that this is my context, this is where I play in. So you can still have a better understanding of processes with RAGs and agents. Access to private data, few short, no, because again, you just have 3 or 4 examples, which is, I wouldn't say very private data. But fine-tuning, RAGs and agents, you can definitely provide your LLMs access to those systems, your vector databases, your image databases. You could have tables in BigQuery. You can provide access to all of that to your systems. Are these auditable? Few shot, no. Fine-tuning, you might have thought yes. But because we are updating the weights, now when the newly trained model is being called, it would just use its weight, but it's not auditable. You never know what it used to generate the answers. So again, if you use them in conjunction with each other, yes, it can be audited. But fine-tuning by itself cannot be. Are we tackling the hallucination problems? Yes, no? Okay. Yes. But not with few-shot learning. It can still hallucinate because you've given only a very few examples for it to learn, so it can still hallucinate. Fine-grained access control, I shouldn't have put this, but I've still put it here because it's not something out of the box. You can do custom builds for fine-grained access controls. None of these would provide this out of the box, but if you create a well-defined governance policy, if you have access controls in place, then you can have fine-grained access control that if I ask a question to my agent versus if someone else asks the same questions, we can get a different results based on what level of access I had. Let's do a face-off. Is grounded actually better? For an example, it's a bit smaller. Hopefully, people on the back can see it. So now if I ask the same question to Gemini Pro, what does Vivanti do? Ungrounded is still saying it's a management consulting firm that's specializing blah, blah, blah. Definitely hallucinating. But on the left side, we have a grounded answer. And it's telling us everything exactly how it should be. Right? So now imagine if you were creating a chatbot or an application that is open to customers, and if you had an ungrounded answer, and someone just asked, what does your company do? Would you want grounded or would you want an ungrounded answer? So by grounding in your private data, this is not a private data set though, but just as an example, you can do that for your private data as well. You can generate more reliable outputs. Another question, what's a compass? It's not a navigation or orientation tool in this context. It's an accelerator that we provide to get to your results faster. So again, if you are a company who had an open chatbot, which is public facing, would you want an ungrounded answer or a grounded answer? Grounded, right? So anytime if you have any public facing APIs or public facing applications, 100% do not go ahead without grounding. And now that you know how important grounding is, let's look at how can we do that, because we don't like magic. So the first service that GCP in itself provides is called an agent builder. It's a low-code to no-code service. So it doesn't matter if you are a developer expert or if you are a beginner into AI. You can use this, click ops, go in and build your own system in an hour. It provides multiple kinds of applications like search, chat, recommendations, and so on. And it can connect to Google Drive, Confluence, your private data on BigQuery or GCS to generate all those outputs. And also it can provide analytics on how your application has been used. What kinds of questions are we getting? Are we actually generating the outputs that we want? How often are we asked questions? So you can get all kinds of analytics out of the box. And here's an example of how it would look. So if you ask a question, it tells you the final summarized outputs as well as where it found the answers from. And it would also give you links to them. So if you see one, so it says that this answer was generated from this link, this answer was generated from link 2, and so on. So it's more reliable and more auditable, right? And taking a step further, we can build a completely custom application. And for that, you have BigQuery's vector search, which is very cheap, very quick to start with. You have Vertex AI vector search, which is super, super fast but expensive. There's AlloyDB and Postgres, much more quicker but still a bit expensive. So unless you have a very specific requirements that you want your results in milliseconds, stick with BigQuery, I'd say. You could still do self-hosted databases, which are Chroma, Face, Pinecone, and there are so many more that you can self-host yourself. You can use Cloud Runs or Cloud Functions, host it and store your state on GCS. Easy. And then taking it to the next level is where you get knowledge with graph databases, which you can integrate vector searches with knowledge databases and get much more accurate answers for complex questions. So just a couple of tips before we wrap things up is if you're building your own custom applications, use serverless offerings because you don't want to spend a lot when you're experimenting. Use vector stores in GCS, store your states on GCS, or use BigQuery's vector search, much more cheaper, a bit slower though, and use Cloud Runs and Cloud Functions. But it gets you started very quickly. LLMs, if you have your custom LLMs, if you've already fine-tuned it, then use Vertex AI's hosted model, managed model hosting, which is a bit cheaper. But if you want to take it to the next level, if you wanted everything under your control, you can use Cloud Run GPUs, which are much more recent development. It just got into GA a couple of months back. So now you can scale GPUs back to 0 and use pay only for your usage. So you're not paying lots and lots of money. So you're just paying for the time you're using those GPUs. Demo time is going to be a bit short, but if you scan this, you would be redirected to a demo that's on my blogs. You can ask it some questions, and you'll see the difference between a Google search and a grounded search. So if you ask some random questions, it's just going to say it does not know the answer to it because it's not grounded on that data. But if you ask some questions which it has access to, that's only when it would give you an answer. So give it a try. But in the meantime, I'll show another demo here, which would be a bit more fun. So I have set up a comparison between ungrounded and grounded answers for all of the LLMs out there. Not all of, but a lot of LLMs out there. So what I wanted to show here is how the answers are generated, or does it matter what LLM you use? So I've just asked a question, what is RAG? Because everyone knows what a RAG is, right? Patrick and me both have said this a lot of times. So I hope everyone knows what a RAG is. So let's see what Gemma said. Gemma said it's a retrieval-augmented generated system, which on an ungrounded system, it's a pretty good answer because it's a very general thing. On the left, it says it's information retrieval, it's language generation, and it can look up answers instead of relying on its knowledge. Which are the key points that we're looking? If we go to some other models, GPT-4 said it's red, amber, green on a project. It's not what we wanted. In some examples, it also mentioned in charities or student organizations, it's called raising and giving. This is, again, not what we wanted. But on the grounded example, you get the exact same thing. You get information retrieval, you get language generation, you get, like the same analogy I said, students sitting on an open book exam. So if you have grounded, you get much more consistent output. Doesn't matter what LLMs you use. Again, on the ungrounded version with ChatGPT 3.5, Turbo, red, amber, green. Same thing on the ungrounded version. You get information retrieval, you get language generation, you get students sitting in an open book exams. So I'll just quickly go through this. So you have Gemini Pro here. A lot of things on ungrounded which are true. Grounded, you get the same analogies that I've said because the grounded answers are grounded on my own documents. And one thing that I want everyone to see is if you check all of the outputs, including Bison, which is not the smartest of the models, information retrieval, language generation, you get all of those things in your answers. And all of the LLMs generate pretty much the same answers. So my question here is, if you have a good retrieval system, if you have a well-engineered backend to get your answers or rank your answers, does an LLM selection still matter when you're creating a chatbot or a question answering system? I'm not giving the answer right now. It's for you guys to think. And hopefully you guys had some time to play around with those question answers. But in summary, just to wrap things up, prioritize your use cases over selecting LLMs. Your LLMs can be swapped around. Maybe some LLMs would be decommissioned in the next 6 months. You'd get a new version of it. So don't prioritize, I need to use Gemini, or I need to use ChatGPT, or I need to use this, or I need to use that. If you have a good prompt setup, if you have a good retrieval system, then your answer should eventually be in the right direction, and then you can play around with a bit. So switching LLMs is easy. Create applications with switchable components. Don't spend hours and hours, or in a lot of scenarios, people spend months deciding what LLMs I'll be using for my system. Spend more time on building what's more important when grounding. LLMs can be switched, and focus on creating high quality data that your LLMs can use. Don't just feed in everything that you have. Find what's important, bring that into your vector databases, and have some ranking systems set in place that your LLMs can use. And that's it. I'm open to questions. Yes, we have some questions.
Do you mind
Yep. That's
questions? I'll start with you.
For the so-called similarity search,
Yes.
are there more than one way to compare two pieces of text? And if yes, which one is?
Sorry, what was that?
Oh, this is not. Is there more than one way to do the similarity search between two pieces
There
of
are
information?
many ways. So vector searches have become the.
And which one is the most popular?
I wouldn't say there's a popular one. There's a lot of ways that you can do searches. So you can do a fuzzy search, for example. usually vector databases have become the way to go, and they do have similarity searching built into most of the databases. So if you just want to get started, choose a good embedding, depending on the use case. If you have images, use multimodal embeddings. So select your embeddings based on that, because that also defines the speed. If your embedding is 2000, that's pretty normal. If it's 10,000, let's say, tokens, then it's going to be slower compared to a 2000 vector embedding. So choose embeddings before thinking about what search I'll use. See what out-of-the-box databases give you for searches, because mostly it's nearest neighbors for a vector search, and see which one are the closest, and you get that.
Thank you.
There's one here.
Thank you. My question was more regarding ML. ML, machine learning. So, like, if someone is a newbie in machine learning, and like they want to create some model, like house prediction model or something like that, and like they come up, with regression. Like, how can a newbie, like, they choose a proper regression, like whether it be linear, whether it be logistic, or whether it be random forest. So what's the best way to choose regression that fit the model? Like, how to choose it? Like, what's the best option to do it?
So what works.
What works? Okay.
So compare all the models against each other.
Yep.
Because a lot of times when data changes,
Mm.
models would eventually change as well. Your parameters and hyperparameters would change as well.
Yep. And the result accuracy is not same at that time. So yeah, that's the thing. Like, how to choose it efficiently so that I get the right result.
So I still didn't get the point.
Like,
So if you already have compared your models.
no. Like, so like, would it be best option to compare the model and choose the best that works for you?
Yes.
Okay, that would be the best option.
There's no silver bullet.
Yep.
You need to pick models based on your use cases, your data,
Mm.
how it's changing.
Mm.
There's no silver bullet. It's not that use this model and you'll win. No, that
Okay.
doesn't work like
All
that.
good then. Thank you.
One more here. I think I'll stand here so everyone else can hear maybe.
Hi. So technically, I understand that the future learning is really suitable for the the data set which don't have too much data. But can you explain why don't we use future learning to route everything or to train any models comparing to other routing techniques?
So you mean why don't we use?
Yeah, why don't we use future learning for routing comparing to the other routing techniques that you told before?
So essentially, it's like a fine-tuning
Yeah.
question, right?
Yeah.
So why don't we use fine-tuning
Yep. Yeah, for example.
compared to RAG?
Yeah.
That's essentially the main question, right?
Mhm.
So it's not that you use one or the other. So fine-tuning is useful when you have input-output pairs. If you already know that for this question I need that answer, that's when you start training your model, right? You train when you know what the output is, and then you can train your model that go ahead, give me this output, this output, this output. Lot of scenarios you don't have an input-output pairs, you don't have question-answers pair. That's when you would go for a RAG. But it does not stop that it's not necessary that you can't use both of them in conjunction with each other. If you have a smaller set of data, if you fine-tune your model,
Yeah.
and then within your RAG model where you use the LLMs, use a fine-tuned model. So you can use both of them in conjunction with each other.
Okay.
All right, that's it. Thank you so much.
Thank you, Yash. It was so much fun learning about the AI hallucination.